Hello friends, in this tutorial we'll be discussing curve fit. It's a part of regression analysis. According to the definition of curve fitting, in the regression analysis, it is used to find best fit line, or in the case of the linear regression, or curve in the case of multiple or non-linear like logistic regression model of the series of data points. Before going further, we'll be discussing what best fit line or best fit curve really is. Best fit line or curve is the way of finding in a line in the case of linear regression that best represent the data on the scatter plot. Like in this case, the line could be like this, passing through this point, but in this case it is scattering only one point. On the other hand, the linear best fit line would be something like this, because it is scattering many of data points in the scattered plot, and if it's not scattering, the other data points are really close to this line. So that's we what say is the best fit line in this case. So if we say that it is a best fit curve, there will be a curve something like this. The curve something like this, which is non-linear. And capturing all the points, it's considered a best curve. So what is the benefit of finding the best fit line of curve? When we if I'm in the next onwards, I'll be just discussing about linear regression to explain the model. We can implement it on other models too, but for the simplicity, if I'm saying regression, just assume I'm talking about linear regression. So if we talk about this straight line, and if its y-intercept and slope is found, we can put it in the slope-intercept format of straight line, and we can also predict the future values of the same scatter plot without knowing any explicit or previous knowledge. So it also helps us to find helps us to predicting the values of the same model of the same scatter plot without just having a previous knowledge of anything. Since we have understood the concept of curve fitting and the best fit line, since the part of curve fitting definition, let's now just talk about how many types of curve fitting are, and what they really do, and their formulas, and why they are different from each other, what their benefit or pitfalls are. The first I'll be discussing is the very most important, easy, and mostly used curve fitting method. It is least squared curve fitting. What it really does, it minimizes the error and it takes the error in the squared form. So in this case, in the regression study, what really does error mean? So error is the difference between original value and the predicted value. Like we can say the difference between this and the line, or like this. these are errors. These are some values, some length, some length unit taken as in this form of measurement, and if we'll be adding all of them, we will just have a value is equals to 0. So since it is an error, we have to reduce it, and if we sum it results in 0. Because the case that some errors are positive and some errors are negative, since it is above the curve showing some positive values and below showing some negative values, sum up results to 0. So what squared error does really is it just squared the values. So this point will be something like here, and all the values become equal. The magnitude will be equal, and then it will sum it to find out what really error is. What is the total really sum error of the curve or the line we made on the scatter plot. And every time it does that, it just try to minimize those errors and result in a very best fit line or curve in the scattered plot. So what is the pitfall? There's a very huge pitfall for using the least squared curve fitting. That is, if the value is something like very far, something like here, the curve fit will exclude that value, and it will just consider the values which are very close and very near, and or on the line like this, something like this values. It will exclude the value from very far, and result may differ from original result or the result we are expecting, or the correct result. There are further types of least root square error. The first is linear. Linear fits the straight line. Basically, it's based on the linear regression. It fits the straight line using the formula given here. And if the line is in the form of polynomial, it uses the formula this. Basically, the difference and the good thing about this is the complexity. The complexity of curvature of the line is dependent on the polynomial degree. Basically, if the complexity of curvature is high, the degree of polynomial increases. If it less, the degree of polynomial decreases. If the line is exponential, something like this, something going like this, so we'll be using this formula. M0 is considered the slope, and M1 is considered the intercept, y-intercept of the equation. Moving forward, if the line is logarithmic, basically if the curve is logarithmic, we'll be using the same formula, this formula, and in this case, same here, same like previous. M0 is considered as slope, and M1 is considered as y-intercept. If the a value is in the power form, it will use this formula. Let's move forward and find out another type of curve fitting, which is non-linear curve fits. The non-linear curve fits are the most powerful curve fit method used, and it's also very popular in using the big data. Why? Because it not really just uses a particular curve fit equation or something like that. It uses the concept, something we call generalized curve fitting. What it used to fit basically uses the generalized curve fit to set the plotted data, means to fit the scattered plot, use the generalized curve fitting method. And now what generalized curve fitting method really is, it based on Leeuwenberg-Marquardt algorithm proposed by this scientist. And what is really does is it use the iterative method, like some instance, like some iterations, specified iterations, and through iterations it make a generalized form of equation. And in the equation, the parameters of the equation in the initially is taken as guess values, and after each iteration it tries to increase after each iteration it tries to increase the efficiency, so the parameters of the equation slightly become correct, and each and every iteration, and at the end the line become best fit. The values change as it is written over here. Values changes after each iteration. Lastly, the another curve fitting method criteria is something we call as smooth curve fitting. Smooth curve fitting are different from other curve fitting types in the types like least squared and non-linear curve fitting, because it do not generate the equation for the result of curve, because there is no single equation in this case. There are multiple equations for in this case, and these curve fitting equations are very useful to just improve the appearance of the plot or drawing the smooth curve. As it is written over here, they don't really generate a single equation. It can be multiple of equations. Similarly, there is no curve representation, and it is very useful in the cases like improving the appearance, like for in case of 3D modeling or something like that. Or it is also used for smooth curve. If we use multiple lines or multiple curves of the same model, the line or the curve would be really clear and smooth and better in appearance. On some cases, in some application, we need multiple curves or multiple curve representation of a single model. So in those cases, we use curve fitting models. So that's it for this lecture. I hope you enjoyed it. Thank you.